Hello students, welcome back to the 7th video of this playlist. So this video will be the last video of this playlist where we will be solving the last question of October 2024 Mechanics-1 paper. So let's see what's the last question of this most recent past paper, that is October 2024 paper. Okay, so you can see question number 7 on the screen. So basically the concepts behind question number 7, it's from chapter number 2, that is uh, motion, that is related to motion mechanics, uh, motion kinematics. Yeah, we need to deal with kinematics equations, the Suvat equations. Yeah, so let's get started with question number 7. At time t equals to 0, a small ball A is projected vertically upwards with speed 8 meter per second from a fixed point on a horizontal ground. Okay, fine. So this is basically projectile motion. The ball hits the ground again for the first time at time t equals to t1 seconds. Okay, so basically the small ball has been projected from the ground in the upward direction. Okay, so it goes up and then reaches maximum height and then falls to the ground. The total journey time is t1 seconds. Okay, so the initial speed, the projected speed is 8 meter per second. Okay, ball A is modeled as a particle moving freely under gravity. Okay, fine. So part A is asking to show that t1 equals to 1.63 to 3 significant figures. Pretty simple. Look, initial speed is 8 meter per second, right? And acceleration is equals to what? Negative g, since we are taking upward as positive. Okay, we will be taking upward as positive, so acceleration will be negative g. Okay, so for part A, taking upward as positive, we will consider which formula to find out the time? S equals to ut plus half of what? At square. Okay, now what's the value for S? Because in kinematics we know that we should at least know three what terms, either three terms from SUV80, right? So since the small ball has been projected from the ground and it is reaching the ground again after t1 seconds, so displacement would be what? 0 meter. Okay, so ut is what? 8t, they said t1, 8t1 plus it will be minus half of g times t1 squared. This is equals to what? 0. Now take t1 common, so you will get 8 minus half of g t1 equals to what? 0. Okay, so either t1 is equals to 0, this is because it was initially at the ground. Okay, or 8 minus half of g t1 equals to what? 0. So what we need the value for t1. So t1 would be what? T1 would be 16 over g. Okay, so 16 over g is how much? 16 over g, 16 over 9.8, that would give you 80 over 49, which is 1.63265. It keeps going. Okay, did they ask for the show that? Okay, so we need to just show that t1, no need for the unit, t1 can be written as what? 1.63 up to 3 significant figures. And that's what exactly part A of question number 7 has asked for. Okay, next is part B. After the first impact with the ground, A rebounds to a height of 2 meters above the ground. Okay, so the ball is, after the first hit with the ground, the ball is getting rebounded to a height of how much? 2 meters from the ground. Okay, fine. Given that the mass of A is 0.1 kg, the mass is given. Now B is asking here to find the magnitude of the impulse received by A as a result of its first impact with the what? Ground. So we need to find out the impulse. So basically the concepts of impulse is from chapter number 6 of your Mechanics-1 textbook, which is momentum and impulse. What is impulse? Impulse is change in momentum. We know that I impulse is what? mv minus mu, right? And it's a vector quantity, right? Okay, so in this case, what? V is the final velocity, u is the initial velocity in the formula for impulse. But here, since it is getting rebounded after the impact, so that means v will be the what? Rebound speed, and u will be the what? Approach speed. Okay, so for finding impulse, mass is known. We need to find out the rebound speed and the approach speed. Okay, rebound speed we need to find out, and approach speed is very simple to find out, because initial speed is what? 8 meter per second. The speed of projection is 8 meter per second, and since it's projectile motion under the force of gravity, so the ball is reaching the same level, that is the ground, after t1 seconds, right? So that means initial speed is equals to the what? Final speed. So we got the approach speed. Approach speed is how much? For part B, approach speed, this is what? U. It is 8 meter per second. Okay, now we need to find out the rebound speed. For rebound speed, take upward as positive. So as the ball rebounds, it is getting to a height of 2 meter. Okay, we took upward as positive, so displacement is 2 meter. Initial speed, we don't know. We need to find out, because initial speed is basically the rebound speed. U should be found. Acceleration is equals to negative g meter per second square, isn't it? And what else we know here? Displacement is 2 meter. Acceleration is negative g meter per second squared, and initial speed we need to find out. Okay, so 2 meter is basically the maximum height, right? So at maximum height, final velocity would be what? 0 meter per second. That's it. So we can easily now find out the what? Rebound speed using this formula. We know the final velocity, we know the displacement, and we know the what? Acceleration. So v square equals to e square plus twice of as. We need to find out what? Approach speed. So u, right? So u would be square root of v square minus twice of as, right? So what you will get? Square root of u squared, sorry, v square is 0. 0 minus 2 times minus g times 2, right? So that is basically u. Initial speed is equals to what? Square root of 4g meter per second. We got the rebound speed, right? So rebound speed, this will be now v, because rebound speed we considered it as v. For impulse it will be v, which is square root of 4g meter per second. Now we need to find out impulse. We are taking upward as positive, so for impulse the direction definitely matters. Okay, so we will take upward as positive, and we will take impulse. I equals to what? Mass is how much? Mass is 0.1 if I'm not wrong. Mass is 0.1 kg, yeah. So mass is 0.1, so mass 0.1 times v minus u. V is the rebound speed, so it is in the upward direction, which is positive. So square root of 4g, that's why positive, minus initial speed, which is basically the approach speed. So approach speed is in the downward direction, so it will be negative 8. So negative 8 makes it positive 8. Fine. So impulse is how much? Square root of 4g plus 8 times 0.1. So that would give you 1.43 what? Newton second. That you must give the unit because they wanted the value for impulse, magnitude for impulse. So unit is must. And so we got the impulse received by mass particle A. This is how much? 1.43 Newton second. And that's what question 7b has asked for. Okay, next is part C. At time t equals to 1 second, another small ball B is projected vertically upwards from another point on the ground with speed 5 meter per second. So after 1 second of particle of ball A has been projected, another ball B is now being projected. Okay, so ball B is modeled as a particle moving freely under gravity at time t equals to t2 seconds, where t2 greater than 1. A and B are at the same height above the ground for the first time. So ball A, it is on one side and ball B is on the other side. Okay, ball A has been projected first. So if I show you this on a diagram, that's better to make you understand about. Look, so this is the scenario. Okay, ball A and this is B. A, B. So for ball A, initial speed is what? 8 meter per second. Okay, and for ball B, the initial speed is how much? The initial speed is 5 meter per second. Okay, this is what? Initial speed is 5 meter per second. So for A, after t equals to t2 seconds, okay, the ball A is at a height of, consider, we are just supposing, ball A, it's at a height of h meter above the ground. Okay, above the ground. And ball B, it's also at a height of h meter above the ground. Fine. Okay, now consider the time. You need to consider t2 seconds because t2 seconds for this is for what? Ball A, because t2 starts from 0. At time t equals to t2, that means it's starting it starts from 0 to t2, right? So this is for ball A. Okay, so ball A has been projected 1 second earlier. That means for ball B, what would be the total time? Since ball B has been projected 1 second later on, that means for ball B, the time would be 1 second less. Okay, that's it. So we got two equations. Now, using this fact, okay, let me see the question. They wanted the value for T2 only. Okay, so using this fact, what we will do, we will form two equations for ball A only. What you will get? S equals to ut, ut plus half of at square. We will use this equation, half of at squared. So for ball A, what we can write? H. S is what? H equals to, we are taking upward as positive. So H equals to what? Ut. Initial velocity is 8 times t2, and acceleration is what? In both cases, acceleration is negative g meter per second square. Here the acceleration is also negative g meter per second square. Okay, ut minus half of g t2 squared. This is for ball what? A only. Okay, next we will consider for ball B. For ball B only, same, upward as positive. Okay, the height is h. H equals to what? Ut. Initial velocity is 5. T2 minus 1, since it has been projected 1 second later, minus half of g times T2 minus 1 whole squared. Fine. Now what we can do? Both the height are at the same level, so both are equal. We can equate them, isn't it? So 5 times T2 minus 1, okay, minus half of g times T2 minus 1 whole squared, that would be equal to what? That would be equal to this one, 82 minus half of g times T2 squared. Okay, so 8 times T2 minus half of g times T2 squared. Okay, now just solve this equation. 5T2 minus 5 minus half of what? G times a squared, which is T2 squared minus 2T2 plus 1 equals to 8 times T2 minus half of GT2 squared. Okay, so look, on the left hand side we have minus half of GT squared, and on the right side we will also have what? Minus half of G times T2 squared. So plus what? Negative half times negative 2, that is plus G T2 minus half of G. This is equals to 8 times T2 minus half of T2 squared. Okay, so on the left hand side we have negative half of GT2 squared. On the right side we have negative half of GT2 squared. Cancels out. So what you will get? 5 T2 minus 5 plus G times T2 equals to what? Or there is negative half of G. 8 times T2. Okay, so take all the terms with T2 on the same side. So 8 times T2 minus 5 T2, this is 3 T2. So 3 times T2 on the right side, this is equal to what? G times T2. Okay, we will take the terms 5 T2 minus 8 T2, this is what? GT2 minus 3 T2, this is equals to half of G plus 5. Now make T2 the subject. So T2 equals to what? Half of G plus 5 divide what? G minus 3. So what would be the value? Let's find out the value. Half of 9.8 plus 5 over 9.8 minus 3. This is basically 99 over 68, which is 1.4558 something. Okay, so the value of T2 is what? T2 is 1.46. The value for T2 is 1.46, and that's what exactly part C of question number 7, that is the last question of Mechanics 1 October 2024 paper has asked for. So up to 3 significant figures we got the value for T2, which is 1.46. Fine.